feel like it's missing.
Okay.
Yogurt,
Okay, guys. So we started 2 days ago with the data types, correct? We started working with the data types. And then we also covered a bit of string, right? So there is so many different data types that we're not going to be able to even finish it today. So if I want to go through every single data type in the book, it's going to take us more than 2 days and we can't waste lots of time. So I'm going to continue covering as much as I can. If we run out of time, you can continue with the slides. And if we don't, and there is also in the book, there is much more information if you're curious about it. Okay, but of course, whenever it comes to quizzes and stuff, it's only the stuff that we take inside the slides. If I don't put it inside the slide, that means you're not responsible on it. For example, I didn't cover pointers because pointers takes lots of times, so I didn't cover it here. But if you're curious about it, you can check the book. And I'm assuming whoever is taking C++, you're covering pointers for sure. So let's go to. Okay. So we started with string. We said, what was the main design issue when it comes to the string? The length, and also if it's static or dynamic, if it's primitive or not primitive. We said why, for example, C will take it as an array of characters. So it's going to treat it as an array, not as a primitive. But then we said Python, for example, it's primitive. Then we said Java, well, it's a primitive like because it's called through a class string. And then we talked about, as I said, primitive, not primitive. And then we wanted to give this example of the C language. We said, okay, in C, strings are treated as array of characters, and they have fixed length based on the array size. For example, what's going to happen here if I attempt to modify within the allocated space, what's going to happen, if you remember? We talked about that there is an issue in C, and that's why it's usually there is a learning curve. It's more. Margaret, you want to? Catherine, sorry.
You modify like the number.
Very good. So exactly. So there will be like an overflow. Why? Because in C, we're going to treat the string or the array, sorry, the string as an array. And then the last character in the array, we're going to put it as a null terminator. And we explained actually, if you put everything in the memory, you're going to be taking from other variables memory. Should I repeat this? I think 2 days ago it's still fresh, so I'm assuming it's good. So we said, for example, if I want to modify 0, like index 0h, it will be very easy for me in C because it's treated as an array. It's treated as an array. So for the people who just came, go inside and take the quiz, the attendance quiz, okay, as soon as possible. But what would be the problem if I want to concatenate something? I want to add, for example, hello world. Now what's happening if I don't do it in a proper way and see, it's going to take some memory, you're going to have an overflow, and then it will be overwrite memory. Yes, Philippe?
There are like libraries to fix that problem?
Yeah, and C, not library, but there is different ways like through memory allocation and other things. That's why I said C is usually more, not complicated, but it's like, there is a bit more like learning curve for it. Now in Java, no, in Java it's different. We said immutable and primitive like, but implemented as objects of the string. Once created, a Java string length cannot change, okay? So what's going to happen if it cannot change? And this will solve the problem of the memory overflow, right? Because I'm not going to be able to overwrite any other memory, because if it's fixed, I cannot change it, even if I want to concatenate something. So how are we concatenating things usually in Java? Exactly. So technically, you are not doing anything. Behind the scenes in Java, it's being done for you. So you have a string, I want to add something to it. Java behind the scenes is creating actually a new memory and copying it here and then adding it there. So everything's happening behind the scenes for you. So that's why we're not going to have the problem when it comes to the thing. I made these not as an image, so you can actually copy it and put it in the online compiler and you can actually see it. I wanted to do it with you, but because we're trying to cover everything today, I'm not going to be able to actually do it. Now in Python, it's very, very flexible, right? Python is very flexible. So it's immutable and primitive. And it's just, okay, you have hello, concatenate creates a new string, R plus word, like similar to the Java ID here. But when it comes to array, we said it's immutable. String is immutable because it's not treated as an array in Python. It's treated as just one word. Yeah? Now, here, please note something that you're going to maybe find it, I don't know, confusing or something. So please go to the quiz and take the attendance as soon as you can. Yes. So for example, here in this summary, you're going to find that we have Python as dynamic length for the string, okay? But actually, in the book, it's static. Okay, so you're going to find when it comes to Python, some sources are going to say dynamic, some sources are going to say static. So here I put it dynamic with a note, but then here I put it in the static length because this is from the book. So this slide's from the book, yeah.
The reason why?
I'm not sure. I didn't have, actually, I searched a bit why there's a difference, but I didn't go deep inside it. I'm not sure, actually. I have to see why different sources are saying different things. But it's a good thing to actually research. It's good. Yes.
In Python, like when you want to like change a string, is it like Java that it creates a new?
Yeah, it creates a new string. Yeah. Yeah, creates a new string for a string. Yeah. So this is just a summary here. And then now we want to talk about the implementation, right? Like, not the implementation, but like the storing in the memory. So if I have a string that is static and another one is dynamic, that means what's happening behind the scene. We're going to check there is a way for the program to understand these things, the difference between dynamic and statics. Through what? Because everything, the same thing, if you remember when we were talking about grammar, right? You have to write everything for this compiler to, for example, to be able to understand the grammar, the steps. The same thing for the computer program. You have to write things. We call this descriptor. Again, in this course, we're not going to go deep into each one, but we're going to give just the concepts and talk a bit about it. And then in some other courses, you're going to dive deep in it. I'm not sure if you even covered it before, for example, with the Java course or something. But let's take an example quickly here. We said this Java, for example, immutable string with fixed length once created. And then now, what is the difference between dynamic length and limited dynamic length? Because here we said C and C++ is considered limited dynamic, even though here we said, okay, it's fixed, for example, right? When we gave this example here. I created this static length, allocate fixed size. But also, and this is maybe more towards the people who are already taking C++, because I'm assuming people who didn't take C++, they're still not very familiar with the idea here. There is also a way to make your array and C limited, not dynamic, but like limited dynamic type. How can we do that? Yes.
You allocate more space than you need in the array?
Exactly. For example, I have here char str equal hello. What's happening here? I have 1, 2, 3, 4, 5. It's allocating automatically 6 spaces, like it's creating an array in the memory of 6 characters because we're adding the null one. This automatically happens because we didn't specify the length. So it's creating this fixed length. But what you can do is actually you can add here inside it, for example, let's say 10. That's mean you're reserving 10, and now you have 6, you still have 4, for example. So that's why sometimes you can actually create, if you know that someone, let's say you're creating, you know, in these forms, fillable forms. I want to say, okay, name, and then I want someone to add his actual name to it. So I know that they will be adding something. I'll say I'm creating an array of 100. And then the name itself, like the word name, it's only what? 5 characters, and I'll have 95 characters. So I'm not going to screw up with the memory. Okay, so that's what's called, guys, limited dynamic length. It's not dynamic, but it's limited because I'm actually specifying it. Now, when it comes to dynamic length, this is usually in JavaScript. It seems like then also C++ with the std string, it makes it dynamic also. So for example, this is the one that I was talking about. If you put 10 here, it's going to be limited. And then when it comes to JavaScript, we have the dynamic length. Okay, so you just add word to the hello, it's just dynamic. Now, what's the difference in the memory for this? Because for us, if we're looking this as just programming, okay, we'll say, oh, you know, JavaScript is the best. It's just dynamic. Why would I need to deal with all of these other things? From what we learned so far about the idea of a static and dynamic, if you remember, when we were talking about the chapter 5 names and stuff, we said, even when you want to have a static type, dynamic type, all of these things, the binding of these things, what's the difference between them? If I want to remind you, so we said there is a static, for example, let's say I say int x. This is a static type. Where is the binding of this variable x happening with the data type? The binding, like when they are putting together at the compile time, because it's static. I write int x, so from the compile time, I decided that this variable x is integer, right? But in Python, if I say x equal 5, this is where is this happening? Runtime. So that's the difference. The same thing here. The problem is that if you have something dynamic like this is going to be updated at the runtime, not only at the compile time. So what's going to happen is actually needs more like memory management and memory allocation. The allocation, there's more what? Not headache, but like there's more work. So if it's not needed, why would I do this? Okay, so that's why usually everything has a pros and cons. So the evaluation, to evaluate something, usually we have to ask, is it better to be primitive or static? These are the questions that we ask each time we want to design something. And then that's what we talked about, the implementation. So if it is static length, compile time, descriptor. If it's a limited dynamic length, this may need a runtime descriptor for length. Why? Because in the beginning, I'll have the fixed length, but also I'll need to have what on top? If I'm writing a descriptor for my program, if it's just a static, I'm going to just give it, okay, this is static length, fixed length. If I'm building a limited dynamic length, so what information I need to put also in the descriptor?
Set the maximum.
Maximum. So you're going to see it here. I'm going to show you. And then we have the dynamic length, need the runtime descriptor. So the descriptor here is a runtime descriptor, not the compile time descriptor. Why? Because we need to work with allocation and deallocation, which is the biggest implementation problem. So if I want to just explain it step by step with you guys, the static length strings explanation is what? Static length strings have a fixed length. It's at a compile time. So these are the two main things. They don't need any additional memory management during program execution. And the descriptor information, what do I need to put in the descriptor for the program to be able to read it? Information about the static string type, and then the length of the string, and also the address where the string is stored in memory. This is also very important because I'm putting the length. Let's say my array is length 10, but where is it? Is it in this room? It's in the memory, so I need the address to the memory. An example for that is this. So that's how my descriptor will be. We'll have the address, length, and static string. Did you cover descriptors in Java or something? No? Okay. So this is the main concept, but actually the script is written like there's a thing. We don't cover it in details here, but maybe in some of your courses you're going to go deep in it. In languages like Java, if you declare a string greeting equal hello, the length and memory address of the str are determined at the compile time and do not change. We mentioned this. Now the limited dynamic length, what is the difference here, guys, is that additional to the length, we're going to give maximum length also. So I'm going to say current length, maximum length. Now the current length is at compile time. The maximum length is defined at compile time also, but in the runtime, it's assigned. So that's why you're going to, a runtime descriptor is used to keep track of the current length if the string changes. And then we have the dynamic length, that's a full runtime descriptor. Because we're going to need the resizing, so we'll need, the memory may need to be reallocated, which is computationally expensive. So if I'm asking you what is the disadvantage of the dynamic length, you're going to say it's what, from a computational perspective, it's more expensive because of the allocation. Yes.
So for the limited dynamic length,
Mm.
and the descriptor, the maximum length, is that the one that we, like, for example, it's the str in square brackets?
Yes, so like you do this, 10 equal, for example, name, whatever, 1, 2, 3, 4, and 5 with the str. So this is the current length, 5. Maximum will be 10. So that's what it means, okay? Now, we're done from the array. We talked about the array. Now we're going to go more into different types. Some of these types, you've already covered it in different courses, and some are new. So the enumerated types, they are sometimes very useful. So they are also called user-defined ordinal types. Okay, so if you've heard this, or if you've read it in the book, ordinal types, usually we mean enumerated. We can declare a list of symbolic constants that are to be treated literally, just like in Prolog or Scheme. We also specify the implicit order. For example, in Pascal is like this. So the enums, if you remember, we've talked a bit about them, and the names is like, for example, let's say you're creating, like here, like the day. So what are the enums here? Monday, Tuesday, Wednesday. But the way that they are defined, why it's useful, because when you define them like this, if you're using Monday, your program will know that Monday comes before Tuesday, for example. Okay, so that's the idea usually of the enum. But so as you can see here, but they are different when it comes to different programming languages. I took two main differences between the C, C++ and the Java, and I'm going to show you what is the actual difference. So here, there's an aid in readability. And why we are always mentioning readability and reliability, guys, if you remember. The first introduction of this course, we say when we are designing, when we are examining any programming languages, we usually want to check its readability, reliability, and other things, right? So these are where you, as a programmer, you're going to check and you're going to assess this programming language based on these things. Now, as you can see here, for example, C#, F#, Swift, Java provide better support for enumeration than C++, for example. So let's see an example here. When it comes to C++, that's how actually enums are worked with. They are treated like integers. Okay, so we're going to define them like this, but red is equal 1. That means green 2, blue 2, 3, and so when you call them, you have this color C equal red. That means if you're printing C, it's going to print 1. Okay, so they are basics. They are very basic procedure. But when it comes to Java, why they are more powerful? Because they are treated actually like objects. So if I'm treating them like objects, I can do more operations on them. Like, so for example, here, if you notice, it's going to be color.red, blah, blah, blah. You can have more functions inside them and all of these kind of things. So enums are more powerful than C++. You're going to ask me, why don't C++ also make them more powerful? Because again, if you remember, we said sometimes each programming language is more beneficial or more suitable for specific applications. C and C++ are usually what? Closer to the hardware. So the simpler they are, the better because of the access, right? They need more faster, all of these things. Java is usually a bit higher level, so they are able to lose more have more flexibility. So I put a summary for you here, guys, if you want. So enums are simpler and more primitive, mainly used for integral constant. Enums treated as integral value and cannot directly be used. Mainly here, as you can see, closer to the hardware and lightweight when it comes to C++. Okay? Java enums are more flexible. Now we covered strings in enums. We're going to move to the array. Array usually will take some time from us. I'll try to go through it. And then after that, I'm going to mention for you some different types that you may be familiar with them, like tuples. You've used it in Python, but for example, we're going to talk a bit about records. So all of these are a bit kind of similar to arrays, but different. We're going to see how they are worked with. So what is an array, guys? We all know that. It's a collection of elements that usually are the same types, right? So that's the idea. So instead of creating, I know that I don't know, I have grades of this class. So why would I create 100 different variables and name them, okay, you know, grade 1, grade 2, or whatever? I'm going to create an array of grades and insert everything. So it's a collection of similar elements. We know this. These are some of the examples when it comes to Java, Python, and C. Now, something that maybe we don't look at it too much, which is arrays and indexes. Arrays are very famous for their index. We cover this in data structure. Why? The index aspect is very important when it comes to the array. What does it allow us to do? Fast access. Access of what? Constant time. So that's the beauty of the array compared to the linked list, which is pointers and you have to follow it and you don't actually know where it is in the memory. So indexing in arrays are also called subscripts. So if you see this in the book or online, when you see subscripts, it means index. So they are used to access the elements, and then array of size n is indexed from 0 to n-1 in the most popular languages. But also we said it can be what? Started from 1 as index. For example, Fortran, which is not used as much. Now there is also multi-dimensional arrays. We've seen this in Python, for example, when we took the CSI3120. These are some examples of the multi-dimensional arrays. Now let's talk about the subscript binding. So this is the thing that usually we miss. Whoever came late, you can take the attendance quiz and then also write your name on the sheet. So if someone didn't still have the sheet, who didn't write their name on the sheet yet? There's still this side and this. Okay. Don't worry about it. You can write it at the end also. Now, what is the idea here of subscript binding? Because what we've talked about so far is the length or the initialization of an array. We said, okay, if this is static or dynamic, I'm allocating memory and all of these things. But what about the indexes in this array? Okay, so there is also the index binding, not just the array itself. Okay, so that's what we're going to talk about a bit here. So the subscript, which is the index binding, this refers to how and when the indexes of an array are assigned values. The binding of the subscript type to an array variable is usually static, okay? The type of an array variable. But the indexes, it can be dynamic or static, the indexes itself. Okay, we're going to see how and why. So there's two types. There'll be static binding of the indexes known at compile time, or it's going to be dynamic binding determined at runtime. So what do we mean by this? Let's take some examples. So these are the array categories. These are the array categories which is define the binding. We'll start with the static array. So if I'm putting something in a static array like the C, Okay, so first, in a static array, the size and memory allocation are fixed at compile time. At this point, we always, whenever we hear static, compile time. Example, in C, we have int numbers. 10 allocates an array of 10 integers in the memory. What is the pros? No allocation overhead during runtime. And then we said the disadvantage of this, that they are fixed size and cannot be resized. So if I want to see it, so what's happening here? If I'm creating this in C++ and I'm doing this, this is a static array fixed size of 5. In C++, if you don't put the static, it's not going to create a static array. Now, I'm not sure if in different courses you already covered the idea of the memory when it comes to stack and heap of the memory allocation, the allocation. Did you cover it yet? Okay, so I'm going to talk about it a bit, but technically it needs its own, lectures and chapters. Yes?
So this array here is a fixed length, or we can't change what's inside the array?
So here we're talking about the fixed size of the array. We were still talking about the fixed size. Now, different programming language, at the end, I have a table. It will tell you some of the languages you cannot change what inside the array at all. Some other languages allow you to change in these. So it differs from different languages. But here we're still talking about the binding. Now, again, I'm going to talk a bit about the stack and heap, but actually it needs a special lectures. So this is the static. Okay, it's straightforward static. Okay, it's fixed, blah, blah, blah. Now, there's something called fixed stack dynamic array. So now here we start talking about dynamic array, but what? It can be changed. But because it is in a stack, it can be only changed or allocated inside the scope or in function. So that's what's going to be a difference. So inside the memory, guys, let's, for example, if we're talking about Java, inside the JVM memory, you're going to have a stack memory, and then you're going to have a heap memory. It's called stack and heap, okay? Usually, the stack is the one that is following the variables, initialization, all of these things inside a scope, inside a function, like local variables. Okay, so for example, you have a specific function that you're calling inside the main function. So a specific function called, I don't know, int. It takes int A and int B, and then it returns A plus B. So now this int A and int B that it's taking it is going to be put in a stack memory. So it goes in a stack memory, and then it's used. Now, the variables usually that they are not inside functions, scopes, inside the main one, these usually go to the heap memory. So again, it's complicated. We don't want to go into details here because it will take us a full lecture, but that's the idea. When it comes to stack, it's related to the scope of the function. When it comes to the heap, it's the general one. So if I'm putting it in the heap, that means what? It will last more with me. The stack, what's going to happen with the stack if it's inside the scope? If I'm done from the function, when I go outside the function, what happens usually to the memory? It's destroyed. It's deallocated. So that's the idea here with the stack. So for example, for the array that they have fixed stack dynamic array, the definition here will allocate it on a stack when the function or block in which they are declared is entered. So if I enter the function, I'm start using a stack, and that's where the memory is going to be allocated. Okay, so what does this mean? If there is an example, I'll wait for the example. So their size is fixed at the point, but only existed during the function's execution. Okay, so the size is fixed, but when it's going to be allocated memory, when I enter this function. Okay, so when I enter the local variable, the function, I'm going to allocate the memory. This will what is the advantage of this? It's going to save space and memory. Why? Because if I have a function, let's say I have a main function here. I don't know how to write without a pen, but let's say I have a main function, and inside the main function, I have another function that it's int add, and it takes A and B, and then it returns C, which is A plus B, okay? So now, this one here, if I have an array, whatever, or what, technically we're talking about array, so it should have an array here. It's not going to be allocated to memory unless I call this function. So that's the idea here. So I'm not going to allocate memory, but it still have a fixed time, a fixed length. Let me erase this. Yes.
So you reallocate the memory every time you call?
Yes, so we allocate and deallocate each time. So that's when what we meant when we didn't talk about the array, we were talking about normal variables. We say, okay, we destroy this. What do you mean by destroy it? So after we're outside of the scope of the function, we're going to destroy it. Like there's a garbage collector, it will collect the. So in C++, if I have this inside the function, int array 5, this is fixed stack dynamic array. Array is created when the function is called. So I'm only going to create this when this function is called. If it's not called, I'm not going to create it in the memory. But here, guys, if I have a static int, the static usually it's always created. Now I have a fixed heap dynamic array. That's another type. Again, I'm putting this underline heap because I want you to link it. When it comes to heap, now we're talking about the bigger memory, not the scope. So what is the difference between this one and the stack? Is going to be these arrays are allocated on the heap part of the memory, meaning they are manually allocated and deallocated by the programmer, okay? That because it's fixed. When we have a heap dynamic, everything is done automatically, but here, it's just a powerful tool when it comes to C and C++. If you don't want to have a fully dynamic because it's going to ruin things for you, like JavaScript or something, I think C#, you can have a fixed. So what do you mean by this? If you've worked with C, who have worked with C before? What do we do? Do you remember what do we do when you want to do a malloc?
Just make the malloc call with
Exactly.
the size that you want.
Exactly. So we call actually, you have to call the malloc. That means you're manually allocating the memory here. In C++, it's, I think, new and delete. That's what you're actually doing. So you're manually allocating memory and then deleting it. So this will allow you to be dynamic, but also it's still in a fixed way, not automatically done by the programming language. So the pros here is that larger and persistent beyond function scope. So now you're not just stuck in the function scope, slightly slower to access than stack allocated arrays. So usually to access the heap is slower than accessing the stack. By the way, this stack is not just one stack, right? So each function will have its own stack. So there will be multiple stacks. And inside the stack, it will be two-dimensional stack. So it will be like this. So it will have the variable here or then the value here. Now it's supported in C and C++. It provides fixed heap dynamic arrays through manual memory, as you said, malloc and free when it comes to C, and then new and delete when it comes to C++. So it will look something like this in C++. If you do this pointer, then you're actually creating a fixed heap dynamic array, but you have to actually do the delete after to free the memory, okay? Again, that's why now you're seeing why learning C++ and C takes a bit more than writing a script in Python, which is you're just randomly writing things. Now also, C# uses a fixed heap dynamic array, but it's actually more like built-in. If you call not the normal array, if you call the array list, it will do usually everything for you. The last one, which is the heap dynamic array, that's like the one that it's fully dynamically allocated in the heap, and it grows or shrinks at runtime, as we said. And this is like in Python, for example, you have this, and then you just do .append for you're just growing the array. This is happening by itself, and then it grows and shrinks as needed. What is the disadvantage? Higher memory allocation overhead. So we need to do the allocation. Very good. So subscript binding and array categories. And that's just from the book, the same thing that I covered with you. I gave you some examples, C and C++ with the static. Without the static will be the fixed dynamic, and then all of these other things. So that's what we just... Now, if I want to initialize it, this is very straightforward. So we want to initialize, and see, you can just do this, this. Why it's all usually sometimes good if you want to just initialize the values from the beginning. Some of the advantages to prevent undefined behavior by ensuring all elements have values from the start, but it's not always it's not always beneficial for you. Now, for example, in Java, there is the automatic initialization. It's going to initialize them to 0 if you don't do anything yourself. Slices, what is a slice? Some programming language actually supports slices, which will take part. For example, if you have this matrix, if you specify mat 0, 0, 2, it will take a slice of the array. Now, the implementation of this array. In programming, arrays are stored in contiguous memory locations. Okay. Now, another thing that we don't think about usually, especially when we talk about the theory. Even in data structure, when we used to talk, okay, this is array because we're using array, we're what? We're actually reserving a chunk of the memory that starts 0, 2, 3, 4. But we don't pay attention. Sometimes we forget that these 0, 1, 2, 3 are what? Are indexes. They are not memory address. So if you remember, we say, okay, this address here may start with, I don't know, like hex something, whatever, right? So it may be something, but then how am I still being able to go constant time and find the address of 2? Usually there is a actual thing, because if I want to keep things constant, I cannot say, okay, because I know there's 0, that means I will start traveling now and start counting, because then I'll be traversing. It's not going to be O of constant anymore. It's going to be what? O of n, and I don't want this. So that means there is a way that's happening behind the curtains for you, which is a memory calculation. So let's see it. So the primary challenge is figuring out where each element of the array is located in the memory and how to access it efficiently. I need to know each element, not just the index 0 where it is. So usually, what do I need? Again, we take this for granted, but there's always there is a descriptor. If you're writing a programming languages, usually they have to follow a descriptor, the same way the compiler will follow the grammar, for example. So array descriptor, during execution, an array is represented by a structure called an array descriptor. As we mentioned, the descriptor contains information about what? Index type. What else do we need? So the type of the index, and then component type, the data type, for example, inside this array, is it an int, is the character, is it what? And then the address of the array. Now, what are the essential information in the array descriptor? To access array elements efficiently, the array descriptor must contain a lower and upper bounds. So what do you mean by lower and upper bounds of an array? The lower bound will be 0. So that's from where is my array. And then the upper bound will be, for example, where I need to stop, because it's a fixed array, for example. Base address is the address of the first index. If I don't know the address of the first index, I cannot calculate the other indexes. And then the element size. Why it's important now? You remember we said, okay, if you're storing int is what?
4 bits.
4 bytes, 32 bits, right? So 4 bytes, that means to make the calculation, again, guys, don't forget, we're doing all of this, you're writing this in English and programming in Java, but actually all of this need to be what? Brought down to the machine language at the end, right? So at the end of the day, it's going to be read it as, okay, this is 4 bytes. So if I'm calculating, I need to skip 4 bytes and all of these kind of things. There's no numbers like randomly index 5, index 6, and going there. And so for example, an int in C is typically 4 bytes. So now if I want to access this array, the element, when you access an element in the array, the subscript or index determines the element's position. This subscript provides an offset from the base address, allowing you to calculate, okay, now calculating the memory address of an array. How? I'm going to cover the one-dimensional array, not the multi-dimensional, because we don't have lots of time. But again, in the book, the multi-dimensional also is mentioned in details how to calculate it. That's actually the formula. It means what? The base address here, so that's the array, and this is the index. So for example, array 0, index 0, I0, I1. The base address is the starting address of the array. So in this array here, guys, that start from 0, 1, 2, what is the base address? When I have an index 0, what is the address that I started with? And then the I is, of course, the index of the element. What is the lower bound? The smallest index value, often usually it's 0 or 1 in Fortran, and then the element size, the size of each element in bytes. I'm not going to need the upper bound for sure here. Why? Because what if this is dynamic, for example? So there is need, in this case, for calculating the memory here, we don't need the upper bound, we only need the lower bound. So let's take an example. I have this array, int array 5, and they have these 5 elements. I want to calculate them. So what's needed from me? What would be the base address? Michael.
It's the address of the first.
So the address of 10, which is the index 0, but I don't have it. Usually it needs to be passed to you to be able to start calculating. These are usually happen. When you initialize an array, usually it's also having the base address. So the base address is the address of array 0. So suppose the array is stored at address 1000. And then we're storing ints, so we know it's 4 bytes. And the lower bound is 0 because this is C language, for example. So can I calculate it now? Yes. So if I want to calculate the address of 2, so that's 0, 1, 2. So this address here. Can I do it? Yes. So if I'm able to calculate it, still constant time to access it. So it's very efficient. So that's what's happening actually. It's not like the machine knows that this is index 2, so it's going to go to index 2. There is no index 2. There is millions of indexes 2 in the memory, right? So there, it has to be translated to machine. So it's going to be like this, 1000 plus 2 minus 0. What is my 2? My 2 is here. That's the index. And 0 is the lower bound time 4, the size. So 1008. And that's how I know how to access. Now, this is the single dimensional array descriptor, as we said. So we'll have an upper bound, lower boundings type, all of these kind of things. Multi-dimensional, we're not going to go through it, but again, it is in the book if you want it. So what else? Associative arrays. What are associative arrays, guys?
An ordered collection of data elements there.
Very good. Very good. +1. If we were in elementary school. Guys, associative arrays, actually, we've covered it in Python course as something, we named it something, and then in the data structure course, we named it something else. Dictionary in Python. In Java, we said there is no built-in. What? Maps. And then we also went with hash maps. If you remember, we said the concept of maps is the idea. So associative array is like this. That means it's an array, but it has a key and a value. It's not just a value. So we'll have a key and a value. And we said, okay, in Python, we have something called dictionary right away. But in Java, we said we have to build it ourselves, the idea of a map, or you can, of course, call libraries or something. And we said the difference between this map that we've taught in data structure, that the keys are unique, for example, in the map. In dictionary, keys are not unique, and we went all of these things. So what is the main thing is that the user-defined keys must be stored. So we need a key. So that's the difference between an associative array and an array. Now, these things may, as again, they are basics for you, but it's good to know what's behind the curtains. Design issues. Again, we're always trying to find what are the issues, static, dynamic, all of these things. And as you can see here, built in, when it comes to Python, we've seen it, the dictionary is actually built in. You don't have to build it. So also known as dictionary or map in many programming languages, it's a data structure that stores data in key value pairs. unlike arrays that use numerical indices to access elements. So here we're not going to access them with the numerical indices. We're going to access them through what? Through their keys. So that's the difference. Very useful. This allows for more meaningful, flexible indexing. Now, instead of randomly, I'll say, okay, I want to access this through index 3008, this random number. No, I can access it right away, for example, calling an actual key, which is, let's say, grade or whatever. So key value pairs, we're just repeating now. So what is the very good thing about it? That there is a fast lookups. Why? Because we can actually use if we want to transform this maps into hash maps, we can use hash functions and all of these kind of things that we've learned before. So let's take this example. This is in Python, right? Built in. So what do you mean by associative? If I want to print Alice, I'll just say person name. I can access this through this, not through an index 0, 1, or 2. I can access it through the key. So that's the idea. Now, another type that I'm not sure if you've used it so far because it's not usually used a lot with the programming language that we covered, which is record. Have you used record before? In which language?
C++.
C++. Yeah, that's true. It's what's called in C++? Struct, exactly. So it's going to, I'll show, I have it here. I'll have it in the next slide. So it's struct when it comes to the C++. But if you only covered, let's say, Java, usually you have to create it yourself through what? Through a class. Okay, you're going to create a class, and then you'll make it like a record class. So that's the difference. C++, it gives you right away. So now, what is the difference here between this and an array? Again, it's it doesn't have to be the same type. So different types under single name. So let's see. So this is one of the main thing. It's heterogeneous. It's not same data type, unlike arrays, which are homogeneous, storing elements of the same type. Another thing is that it has a fixed structure. Once defined, the structure of a record type does not change, okay? Name fields in a record are accessed by their name. So in C, as you can see here, we have the struct. It's already ready for you. You can use it. So you're going to say struct name, and then you're going to have different types inside them. So it's a very, very useful thing to have. Now, if you're using you can use it like this. You're just creating the person, blah, blah, blah. But here in Java, you have to actually create a class for it. Class person, and then you do it yourself. But this is actually still an idea of a record. So very good. So hopefully, guys, for the next lab, we'll try to do different things with these more practical stuff. Yes. Yes, so it's like a record, like literally, that's why we call it record. But I'm not sure exactly because they are different between C++ and Java. So from between different languages, there's different things. What we can do, that's what I'm aiming to do in the labs for next week, is to actually take only 2 languages. Let's say, for example, C++ and Java, and we'll try to build the same exact function here, and see actually what is the main difference. So we're trying to actually do it inside the lab, guys. So here we're just, covering the concepts of things. By the way, for the people who already went to Wednesday's lab, if you see there is something that we can actually also improve to make the learning curve, especially with the people like who've covered, like, for example, remind me with your name, Eric. Eric, for example, you covered more languages, C++, Java. If you felt there is also something that we can add to these practical labs, send me an email about it. People who took C++ and Java, for the next lab, we can actually try to improve the practicality of the examples, okay?
Still going around.
The paper of the attendance, if you want to pass it, yeah. Now, tuple types. Let's go through the tuple types. What is tuple? We've taken in Python, right? You can also store different types, correct? So with the tuple, we can store different types. So what is the difference between a tuple and a record? If both of them, we can store different types. The main difference is, yes.
Immutable.
Sorry,
What's like immutable, like, and once you define
which one? Yeah,
immutable.
immutable. Yes, and also another thing is what? You have to access it by index. That's another thing. So these are the two main things. So it's fixed, ordered collection of elements where each element can have different types. So it is true that you can have different types, but it's still fixed and ordered. Tuples are often used to group related values without creating a full-fledged custom data structure, like, for example, other things. So the key characters here is that it's fixed length that cannot be changed, as Ibrahim said. Ordered, and then what do you mean by ordered here? That means if I want to access it, I'll call the 0 or 1 or 2. So there's an order here, but also it can have different types. So usually it will happen like this. So you have a tuple in Python, Alice 35, and then when you call this 0, 1, 2, you'll be able to access them. So it's not super organized if you want to use it as a data structure, like to have something, but it's useful for other type of things. Now, these are some of the differences between tuple and arrays that I put here as a conclusion, as a summary. And then also, what is the difference between record and a tuple? We just covered it. The main difference between them is how they handle data structure and element identification. So just one thing. So the element identification, which is, as we said, is it by index? Is it 0, 1, 2? How do I access it? Or through the fields or names? And then usage contexts. We covered this also. Let's just go right away here. So that's a tuple. If I want to access 10 or 20, I have to access like this in Python. But in a record, you can just point like X or Y, and then it'll have it. So this is one of the main differences. Yes, Benj.
How would you classify an array of something like that has type like iterable or numeric or even object in Java?
Would you what? Initialize it?
How would you classify an array that has a type like object or iterable or numeric?
I'm not sure. Not sure if it's possible, or I have to double check. Actually. But we'll double check and see how we can do. And I think that's it for this. It's lots of data types. As I said, there are still pointers, there's still other things, but it's going to be boring if I continue just naming them. But we covered as much as we can. And the labs will create something that is more practical for you when it comes to this. Now, when it comes to our topic that we're going to cover next, one of the topics, most probably I'll be recording it and posting it. And then we're going to, so I don't waste another lecture on next Wednesday, okay? Because we still have few topics that we need to cover before the final. We still have to go through object-oriented stuff, polymorphism. There is the control structure. There is lots of things. So that's why I'm going to be recording most probably one topic for you that you can watch before Tuesday's lecture. Okay, guys? So we're done.